Hi and welcome to Intro to Trig Day 6. Today we're going to work with reference angles again. So, reference angle we said is an angle which is positive and acute, and it's between the x-axis and the terminal ray. So, just to kind of review what we did yesterday, to find the reference angle in quadrant 2, our triangle would look like so, and my reference angle would be 180 degrees minus theta. In quadrant 3, my reference triangle would look like so, and I would do theta minus 180. And in quadrant 4, my reference triangle would look like this, and I would say 360 minus theta. So for our examples, point A is 1, 0, and this should be a B here, sorry, my mistake. B is the point 3/5, 4/5. On the unit circle O, if the measure of angle AOB is equal to theta, find. Remember, we really are only concerned about this point there. Point A just lets us know that we're on the unit circle. Okay, again, everything is in the form of x, y, and as an ordered pair, it's cosine theta, sine theta. So this is going back to what we did a couple of days ago. The sine of theta is 4/5. The cosine of theta is 3/5. Our x value is the cosine, our y value is the sine. Our tangent, remember tan theta, is equal to y over x. So in this case, it would be 4/5 over 3/5. Multiply top and bottom by 5, because that's my LCD, and that's 3. So my 5's cancel out, and I'm left with 4/3. Okay. And 2 through 4 express as a positive acute angle, and then find the exact value. Well, as a positive acute angle, I am in quadrant 3. The big angle is 225 degrees. When I'm in quadrant 3, I need to take theta minus 180. So 225 minus 180, and I get 45. And in quadrant 3, sine is negative, so it's a negative sine of 45 degrees. B says to find the exact value. Well, the exact value of sine is 45. That's your 45, 45, 90 triangle. My sides are 1, 1, radical 2. So the sine is opposite over hypotenuse, so it's 1 over root 2, which we can't keep, so we have to change it to root 2 over 2. And since this is a negative sine of 45, my answer would be a negative radical 2 over 2. The cosine of 120 degrees, well, cosine of 120, that puts me in quadrant 2. And in quadrant 2, I need to do 180 minus theta. So 180 minus 120 is 60 degrees. I'm in quadrant 2, so that means that cosine is negative, so it's a negative cosine of 60 degrees. So I need to draw my 30, 60, 90 triangle. 1, 2, radical 3. And cosine 60 is adjacent over hypotenuse. So it's a negative 1/2. And the cosine, so for number 4, the cosine of 300. 300 is in quadrant 4. Okay, so in quadrant 4, we do 360 minus theta, which is 300. So that gives me 60 degrees. And in quadrant 4, the cosine is positive. So it is the cosine of 60 degrees. And the last problem, cosine of 60 was 1/2. And it was negative because it was in quadrant 2. But in this case, we're in quadrant 4 and cosine is positive. So it's a positive 1/2. Okay, in case you don't remember how I remember what's positive and what's negative, it's all students take calculus. All right, next page. Find the exact values. Well, what I've done is kind of drawn some pictures here so we can, or axes here, so we can draw our angles. 240 degrees puts me in quadrant 3. And in quadrant 3, I will do 240 minus 180. So it's theta minus 180. And that gives me 60. So, let's see here. 60, I'm going to need my 30, 60, 90 triangle. And it's 1, 2, and then radical 3 here. And I'm probably going to end up using my 45, 45, 90 triangle as well. So let's just get that drawn. Okay, so 60 degrees, and I'm talking, it's the sine, and in quadrant 3, it's negative. So the sine of 60 would be opposite over hypotenuse, so radical 3 over 2, and since I'm in quadrant 3, it is a negative radical 3 over 2 plus the cosine of a negative 300. Well, a negative 300, I'm going to go this direction, and that's actually going to put me in quadrant 1. And if I'm going a negative 300, that means the positive angle is 60, because they're coterminal angles and they have to add up to 360. So what is the cosine of 60? Well, cosine of 60 is 1/2. I'm in quadrant 1, it's positive, so it's 1/2. So to combine these, my denominators are alike, so I just put it over 2, and it's negative radical 3 plus 1. Okay. For number 6, the sine of 60, go back to our right triangle up at the top. The sine of 60 is radical 3 over 2 plus the sine of 30. Well, the sine of 30 is 1/2. And then the quantity squared. So the very first thing I need to do is add inside my parentheses. I will have radical 3 plus 1 over 2, the quantity squared, which means write it twice. Oh my goodness, those darn radicals are back. So I need to FOIL in my numerator. Radical 3 times radical 3 is 3. Radical 3 times 1 is plus radical 3. Another 1 times radical 3 is another plus radical 3. And then 1 times 1 is plus 1. I didn't mean to write equals plus 1 all over 2 times 2, which is 4. If I combine like terms, I will have 4 plus 2 radical 3 over 4. They all have a 2 in common. Cover up the radical 3. I have a 4, a 2, and a 4. And they all have a 2 in common. So if I divide everything by 2, I will get 2 plus radical 3 all over 2 for my final answer. Last one. The sine of 120 times the cosine of 210 minus the tangent of 225. So sine of 120, that puts me in quadrant 2, and in quadrant 2, I'm going to do 180 minus theta, so I have 60. So the sine of 60 is radical 3 over 2. It's positive because I'm in quadrant 2 and sine's positive. Cosine of 210, well, 210 is going to put me in quadrant 3. And in quadrant 3, I do theta, which is 210 minus 180, which is 30. The cosine of 30 is also radical 3 over 2, but I'm in quadrant 3, and in quadrant 3, cosine is negative. Minus the tangent of 225. Well, 225 again puts me in quadrant 3, so I'm going to do theta minus 180, which is 45. And tangent is positive in quadrant 3, and the tangent of 45 is 1. So let's do the math here. Radical 3 times negative radical 3 is negative 3. And then 2 times 2 is 4. Minus 4 over 4. So I get negative 7 over 4 for my final answer. All right, so that was a review using our reference angles and some of the other topics that we have learned in this unit.